Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper, and for this purpose we have selected May-June 2010 2 paper. This paper 2 belongs from the Zone 2. In this paper, there are two sections, Section A and Section B. In this video, we are going to attempt the Section A of this paper. The Section B of this paper, I will attempt in another video, and soon I will upload that also. So let's start Section A. We are going to solve this paper in this video. So let's start today's paper. May-June 2010 2 paper, the showing up on your screen, and the section A we are going to solve today. Time allowed for this paper is totally 1 hour and 45 minutes, and there are 75 marks for this paper. So here we go. Question number 1. A journey consists of two displacements. The first is 500 meter in a northerly direction, and the second is 200 meter in an easterly direction. In the space below, draw to scale a vector diagram of these displacements. State the scale of your diagram. On your diagram, show the two displacements and the resultant displacement. Determine the size, the magnitude, and direction of the displacement. So we have two displacements, and one displacement is of 500 meter, and it is in the north direction, and we have 200 meter, which is in the east direction. So they are mutually perpendicular to each other. So we are going to use a parallelogram law to find the resultant of these two vectors. Okay, so here we have that space is given. So let me show you the whole thing. So here we have the 3 marks question. The space is given. So first of all, I have to choose scale. So let's say I will choose, let's say 1 centimeter represents, suppose we choose the scale that 1 centimeter represents 50 meter. So the 500 meter will be represented with a length of 10 centimeter, and the 200 meter will be represented with a length of 4 centimeter. So here you see I have drawn a diagram. So here I have, let me show you. This solution has been done by one of my students. Her name is Aisha Akil, and thank you very much for her solution. So here we have that line, that vector, which represents 500 meter towards north. Here we have that other vector, and which is 4 centimeter long, which actually represents 200 meter. They are mutually perpendicular to each other, so that means that angle here is 90 degree. So you can see that we have placed these two vectors to be added in such a way that their tails are joined together. So then I will complete the parallelogram. And how you complete the parallelogram? You suppose that these two sides, vectors, they are the adjacent sides of a parallelogram. So you open your compass 10 centimeter, you place the compass here, and you draw this arc, because equal to this will be our side here. So open your compass 10 centimeter, place the needle of the compass here at this arrowhead, and draw the arc here. Then open your compass 4 centimeter. Open your compass 4 centimeter. Place the compass needle here and draw the arc where these two arcs intersect. Join that point with this and join that point with this. So your parallelogram is completed. Okay. So then where the tails were joined, join that point with the opposite corner of the parallelogram, and that line will represent the resultant vector. So I will join this with this point, and this is 10.8 centimeter long. So because it's 10.8 centimeter, 1 centimeter represents 50 meter. So 10.8 multiply 50, and that will be 540 meter. 540 meter. So that is the answer. And if you want to find out the direction, I will measure this angle, and because this line is representing north and this line is towards the east, so measure this angle when you will measure between these two lines, north and this resultant, and this angle is 22 degrees. So your angle is 22 degree north, 22 degrees to east. That is the direction. So let's have a look at let me reduce the size so you can see the whole thing together. So you can see, I hope, the whole of this solution on your screen. And here we go. This is the marking scheme. And here is the marking scheme for the question number 1, and it's A part. So their answer is 540 plus minus 10. So our answer is exactly 540. This is the marking scheme. And this is the solution. And we are going to the next question. I mean the next part. The next part is question number 1. It's B part. He says another journey covers a distance of 700 meters. Describe how it is possible that this journey has no resultant displacement. Okay, so distance means the length of the track, the length of the path you followed. But the displacement is the shortest distance between the starting point and the finish point. So it's possible that when you have traveled 700-meter distance, but your displacement is 0, when this happens, when your starting and your finish point is the same point. So, for example, if you start moving from the point A, and for example, you went like 350 to point B, and then you came back from point B, you came back to the point from where you started. For example, you went 350 meters away from point A, and then you came back 350 meters to the same starting point. So your displacement will be 700 meters, but your distance will be 700 meters, but your displacement will be 0, because your starting point and your finish point, they both are the same point. So your displacement will be 0. Okay, so let me show you our written answer. And these answers are written by one of my students. She is studying under my supervision. The person who covers the journey returns back to its start point. So if you come back from where you started, your displacement will be 100% 0. So you can quote this example also, that from point A, you went to point B 350 meters away, and then from point B, you came back to point A. So the total distance traveled will be 700 meters. You can quote this example as well, and your displacement will be 0. So this is the marking scheme. So we are done with the question number 1. I hope you understand. Okay, so here we go. He says question number 2, figure 2.1 shows a motor used to operate a lift, which we call elevator. There is a man in the lift. The input power to the motor is 6,200 watts. Define the watt. Watt is the amount of the energy transferred in unit time. Or you can say the amount of work done in unit time is known as watt. And if 1 joule energy is transferred in 1 second, we will say this is 1 watt. 1 watt is the transfer of 1 joule energy in 1 second. Or if 1 joule work is done in 1 second, we will say that the power is 1 watt. So this is the definition of the watt. And the next question on your screen is, he says the lift and the man have a total mass of 580 kg. The lift moves up a distance of 12 meters in 15 seconds. Calculate the tension in the cable when the lift is moving at constant speed. The tension in the cable will be equals to because the direction of the tension will be in the upward direction, and in the downward direction will be the weight of this man and the lift. So the weight of the man and the lift will be W equals to mg. So the m value here is 580 kg, and the g value we take 10 Newton per kg. And remember, from 2023, this value will be taken as 9.8 Newton per kg. But in this paper, we are taking 10. Okay, so the weight will be, the total weight will be 580 multiplied 10. That will be 5,800 Newton. So the upward tension will be equal to the downward force, which will be the weight. So that upward tension will be 5,800 Newton. 5,800 Newton is the right answer, sir. Okay, so the second part of the question number 2b, calculate the increase in the potential energy of the lift and the man. You see the potential energy, the formula is mgh, the gravitational potential energy, and that the formula for that is m and g and h, where m means the mass, g means the gravitational field strength, and h means the height you have moved upward or downward, you can say, because here is the gain, so it is going upward. So mg means the weight. The formula can also be written as weight multiply the height. This is also the mg means the weight. The weight here is 5,800 and Newton, multiply the height is 12 meters, so you will get the answer. I have done this here. You can say 580 multiply 10 multiply 12, that is 69600, and that is 6.96 expo 4 joule. 6.96 expo 4 joule. 6.96 expo 4 joules, and that is right answer, sir. Okay, then we have calculate the efficiency of the motor, and you know to calculate the efficiency of the motor, that is equal to the total input energy is power multiplied time. The power here is 6200 multiply 15, and that will be 93000 joule. Output energy is that which you have just calculated the gain in the gravitational potential energy, that is 6.96 expo 4 joules. The efficiency is the output, useful output energy divided by the total input energy multiply 100. So it will be 6.96 expo 4 joule, and divided by 93,000 joule multiply 100, that is 74.8%, which is approximately 75%. So 75% is the right answer, sir. Hopefully you understand. If you have some doubt that from where this input energy is coming, we know the power, and we know that how much time it took. It took 15 seconds. Here is the time given, and here is the power given of, you can calculate the input power. Then you can calculate, so input power is given, you can calculate the input energy. So I hope you understand that how this is done. And let's go to, this was the answer. We are done with the question number 2. Okay, so we are going to the next question. That is question number 3. He says figure 3.1 shows a metal roof. One side of is facing the sun. Okay, so this is a metal roof. This side of the metal roof is facing the sun. State the means by which the thermal energy, heat, is transferred from the sun to the earth, and explain why other means of thermal energy transfer are not involved. You see, the thermal energy is transferred by 3 methods. They are conduction, convection, and radiation. Conduction and convection, both these methods of transfer of heat, they require medium. And because between the sun and the earth there is vacuum, there is no medium, so that by the process of conduction and convection, the heat cannot be transferred from the sun to the earth. Then the third method, which is radiation. Yes, from the sun, the heat can be transferred to the earth by the radiation. And for this purpose, infrared rays are used. From the sun through the infrared rays, the thermal energy reaches the earth, and that do not require any medium. So let's have a look at the answer. Okay. So energy from sun is transferred to earth in the form of infrared radiation that can travel through space, but medium is required for conduction and convection. That's why through them the energy cannot be transferred. That's question number 3. A part you can see is a 2 marks question. The marking scheme is showing up on your screen. And is it radiation or infrared rays or electromagnetic wave travels through space vacuum or does not require medium molecules or particles, or medium required for conduction and or convection or for other methods? So our answer is good. Okay, so we are going to question number 3. It's B part. It says describe how thermal energy is transferred through the metal roof from the heated surface. Describe how thermal energy is transferred through the metal roof from the heated surface, because they're talking about the metal roof. So through the metal, how the energy will be transferred, through the heat will be transferred in the metal by the process of conduction. And you see the molecules which are on the hot side of the metal, they start vibrating vigorously. The amplitude of their vibration increases, so they make their neighbors vibrate vigorously. Their neighbors, the amplitude of vibration increases, and in this way, through these vibrations, the heat is transferred from the hot end to the cold end. Another way, because the metals are good conductor of heat, so they have metals have free electrons in them. So what happens by the free electron diffusion? Also, the heat is transferred from the hot end to the cold end. So at the hot end, the electrons, free electrons, they absorb energy, and they flow. They go to that end where the which one is cold, and there those free electrons, they collide with the molecules and they make them vibrate vigorously, and in this way the heat is transferred by the flow of the free electrons from the hot end to the cold end. This is called free electron diffusion. So let's have a look at the question number 3B part. Its answer: heat energy is transferred by conduction through the metal roof. Vibration is passed on from one particle to another. Electrons also move and hit the other particles to transfer energy. This is called free electron diffusion. So heat energy transferred by conduction through the metal roof. Vibration is passed on from one particle to another, and electrons also move, and these are free electrons, not the normal electrons, they are the free electrons. Free electrons also move and hit other particles to transfer energy. Okay, so this is how this is done. Have a look at the marking scheme. It says conduction occurs or atoms, particles, molecules vibrate, or electrons given energy, heat energy, vibration passed on from one particle to another, or electron moves to other parts, diffuse, hit atoms. So not just focus on this written answer. This written answer is written by one of my students, and but the answer which I am also describing, and the answer which is written in the marking scheme, the answer which she has written, just write your own answer. Okay, these are just guidelines for what you have to write. Okay, question number 3, C part. During the night, the metal roof loses 1.2 expose 6 joules of thermal energy, and its temperature falls by 20 degrees centigrade. The specific heat capacity of the metal in the roof is 400 joule per kg per degree centigrade. Calculate the mass of the metal in the roof. Okay, so the amount of the energy is given, and the temperature, the change in the temperature is given. The specific heat capacity is also given. Whenever there is a change in the temperature, we use always the formula that heat is equals to MC MC delta theta. Okay, so the heat is equals to the MC delta theta, and by using this formula I can calculate the mass. I will make this M alone and I will be able to find out. So here we have the mass. This is 1.2 x power 6 equals to M into 400 into 20. So the M will be equals to 1.2 x power 6 divided by 400 divided by 20, and that will be equals to 150 kg. So the mass of this thing is 150 kg. So 150 kg is the right answer. So my dear students, I am done with the question number 3, and the C part is the numerical when the temperature changes. Okay, so let's question number 14. A student notices puddles of water on a road as shown in the figure 4.1. So these are the puddles of water on the road. And it says later in the day he passes the puddles again and some of the water has evaporated. State 2 changes to the atmospheric conditions that could cause the water to evaporate faster. So how the rate of evaporation can be increased? The rate of evaporation can be increased if the temperature of the atmosphere will increase, or the wind starts blowing, and the humidity level it drops. And these are the few factors which can cause the water to evaporate faster. So increase in the temperature, wind or air, less humidity, less pressure. Okay, so our answer is right. Then he says, explain in terms of the molecules what happens during the evaporation. Listen carefully. The molecules of the water which have higher kinetic energy, when they come to the surface of the water, they overcome the intermolecular forces and they overcome the atmospheric pressure. And from the surface of the water, they go into the air. And so in this way, the evaporation takes place. So what happens then? The molecules which are left in the water, they have less kinetic energy. So due to this, the average kinetic energy of the water decreases and the temperature of the water drops. During evaporation, more energetic molecules on the surface of the water breaks bonds with the neighboring molecules and escape into the air, leaving behind less energetic molecules. So the question number 4, it's marked say molecules, atoms, particles escape, leave surface, or molecules become gaseous, vapor, or molecules break bond. Molecules with the largest energy, higher speed, sufficient or enough energy, escape, break bonds, become gaseous, or leave behind slow or less energetic molecules. So that was question number 4. This is the answer. And here we go. Figure 5.1, this is question number 5. Figure 5.1 shows a ray of light entering a semicircular glass block and striking the glass surface at M, the midpoint of the straight face. So this is a semicircular glass block. This is its straight face. This is its curved face. And here we have the light is striking the midpoint of the straight face. The ray of light strikes the glass surface at M with an angle of incidence, capital C, equals to the critical angle of the light in glass. State what is meant by the critical angle. The critical angle means the angle of incidence in the dense medium for which the angle of refraction in the rare medium is of 90 degree. That angle of incidence in the dense medium is called critical angle. This is the definition. Okay, so here we go. The critical angle is the angle of incidence in dense medium for which the angle of refraction in the rare medium is 90 degree. So here we have that definition. Okay, so then we have question number 5a, second part on the figure 5.1. Mark and label the angle C. And then the third part is on the figure 5.1. Continue the ray of light after it strikes the glass surface at M. So, so I will draw a normal here, and so we will draw a normal here, and this is the angle of incidence, and this will be called critical angle. I will label it as C, and because the when the angle of incidence here in the dense medium is equal to the critical angle, the light will start moving on the surface of the glass. It will start moving along the boundary of the glass and the air. Angle of refraction here is, if you prolong this normal here, this angle will be of 90 degree. So I hope you understand both these parts, and let me show you the answer. Yeah, here we go. Here we go. Here we go. Question number 5, it's B part. He says figure 5.2 shows a second ray of light striking M. This ray has an angle of incidence at M smaller than the critical angle. On the figure 5.2, continue this ray of light after it strikes the glass surface at the M. Because the angle of incidence is now less than the critical angle, so now the refraction of the light will take place. The light will enter into the air. So when it will enter into the air, it will bend away from the normal, and you don't have to do the calculation here. You just have to change the path of the light. This was the original path. It will bend away from the normal. So our answer is right. Okay, then they can say the refractive index of this glass is 1.5. A third ray of light enters the glass block from air with an angle of incidence of 50 degree. Calculate the angle of refraction. You know, here we use the Snell's law. The Snell's law says that the n, the refractive index, is equal to the ratio of the sine I by the sine R. Here the light is entering from air into the glass. The refractive index of this glass is 1.5 m 5.8 1.5, sorry. A third ray of light enters the block from air with an angle of incidence. So in this formula, n is equals to sine I by sine R. Sometimes this formula is n is equals to sine R by sine I. Depends which formula you will use, sine I by sine R or sine R by sine I. That depends on that which angle is in the rare medium. Whichever I or R, whichever angle is in the rare medium, that should be in the numerator. So here the angle of incidence is in the rare medium, so it will be in the numerator. So refractive index is equals to sine I by sine R. So it will be 1.5 equals to sine 50 divided by the sine R. So the R will be equal to sine inverse of the sine 50 divided by 1.5. Just enter these values in your calculator, you will get 30.7. So the angle of refraction will be 30.7. 30.7, which is approximately 31. So our answer is right. Here we go. Question number 6. An aeroplane becomes positively charged as it flies through the air because it loses particles from its metal surface. State the name of the particles lost from the metal surface due to the friction. The electrons will be lost. The electrons will be lost. Electrons is my answer. Electrons, you can see, look at the from the marking scheme. Then he says, question number 6a, second part, the tires of the aeroplane are made from an electrical conductor. Explain what happens to the charge on the aeroplane when it lands. So when it will land, because its tires are conductor, so what will happen, because the body of the aeroplane has become positively charged, so when the tires will touch the ground, from the ground, the electrons will be transferred to the body of the aeroplane and it will be neutralized. The body will be neutralized. Charge becomes zero and aeroplane is neutralized as electrons move from the earth to the plane because the plane was positively charged. So this is the marking scheme. You can pause the video. You can take your time. Okay. So then we have question number 6b part. Suggest why it is necessary to keep an aeroplane connected electrically to earth during refueling. You see, when you refuel, the fuel also becomes charged. When the fuel flows in that pipes, it also becomes charged. And if the body of the aeroplane is also charged, then what will happen when the two charged particles, they will meet each other, the sparks will be produced, and there will be fumes of that fuel, and an explosion can take place due to those sparks. To avoid this, what we do, we connect the body of the aeroplane and the nozzles of that fuel pipe or that hose, we earth them, and by doing this, what we make sure that they do not get charged. So aeroplane stays uncharged to avoid any spark or explosion. So this is our answer, and the marking scheme is also showing up on your screen. And I told you that whenever you write the answer, listen carefully what answer I also describe the answer, and then there is a written answer, then there is this marking scheme. Join them together carefully, and then write your own answer. So let's go to the next question. The next question is question number 7. It says figure 7.1 shows a compass. This is the compass needle. Remember, the compass needle is a magnetized. It's a metal, it's made of steel, and it is magnetized. The compass needle is a small magnet free to rotate. The head of the arrow on the compass needle is an north pole. A bar magnet is placed between two compasses as shown in the figure 7.2. On the figure 7.2, draw the needles inside the two compasses and mark the north pole of both compass needles. Okay, so because the compass needle always align itself so with the magnetic lines, so the magnetic lines here will be going towards the south. So the its magnetic compass will be needle will be pointing like this. Its magnetic needle will be pointing like this, because the magnetic lines here are going like this, the magnetic lines here are going like this. So the magnetic compass needle always align itself with the magnetic lines. Wherever they are going, the magnetic compass needle points in that direction. So this is how you will show this, and it's a 2 marks question. So let me show you here also, we have done. So here you can see the North Pole, we have shown this also. This is the marking scheme, question number 7. This is the question. Okay, then the question is question number 7b part. Figure 7.3 shows the structure of a relay. Okay, explain how closing the switch causes the contacts to close. Okay, so when you will close this switch, this coil, through this the current will start flowing, and this soft iron, it will become electromagnet. It will attract this vertical portion of the soft iron towards left. And when this will be attracted, this soft iron piece will be attracted to this electromagnet, and this soft iron pivoted here. So when this will be attracted to this way, its horizontal portion will move in upward direction automatically. This will lift this contact and it will touch this contact. And the current in this second circuit will start flowing. This is how a relay works. Okay, so listen carefully. When the switch closes, current flows into the circuit and iron inside the coil becomes a magnet. It becomes an electromagnet. The magnetized iron attracts the vertical part of the iron armature. Horizontal part of the iron armature moves upward and push a downward contact upward, and push instead of using the word downward contact, use here the lower contact. It will push that. Aisha wants to say the lower contact. The lower contact means this contact, this one, this is the lower contact. Okay, so and push the lower contact upward, and both the contacts close. And obviously in that circuit, the current will start flowing. This is the marking scheme of that answer. You can pause the video. This is question number 7. It's B part. I hope you understand. Okay, here we have. This is question number 7, C part. He says figure 7.4 is a circuit that includes a relay. When light shines on the light-dependent resistor LDR, the relay contact C close. State what happens to the resistance of the LDR when the light falls on it. When the light falls on the LDR, the resistance of the LDR decreases. So the resistance of the LDR will decrease. And okay, then their question is, The circuit for the lamp as shown in the figure 7.4 is not complete. On the figure 7.4, draw the connections to the lamp, the contact C, and the battery that causes the lamp to switch on when the light shines on the LDR. So here we have to complete this circuit. So you will add a battery here. So you can add a battery here. Okay, like this. Okay. Let me show you. I have done this. And where is that? Where is that? Okay, so you can see here. So the circuit has been completed. So this is the, okay. So this is the answer, sir. So we are done with the question number 7. Now we are on a question on question number 8. A radioactive rock emits gamma rays. A teacher plans an experiment to show a class that the emission of gamma rays from the rock is random in time. State the apparatus that the teacher needs to detect the gamma rays. So to detect the gamma rays, normally we will be using famous GM tube, the Geiger-Müller tube. So GM tube. So we are going to use the GM tube, okay? So, or any other gamma detector, okay? Then the question number 8, second part, he says, state one safety precaution that the teacher must take. Don't directly touch the radioactive material. Always use tongues to hold it. Always use forceps. Always reduce the exposure time to minimum. Wear the aprons who have lead lining in them. Use the gloves which have lead lining in them. Okay. So keep distance from radioactive source and handle it with tongues, because this is emitting gamma rays, so it's not enough. Keep distance, for example, forceps, tongues, barrier except gloves, lead suit, metal container, time for use. Okay. Then we have, he says, describe how the experiment is performed. It's a 2 marks question. So we have to describe how the experiment is performed. He has to show that the emission of the gamma rays is random. So when you will use the GM tube and you will note down the reading, for example, after 5 minutes or after 2 minutes or after 1 minute, you are noting down the reading. So you will observe that the reading on the GM tube will be fluctuating. And sometimes it will be more than the less, and it will be fluctuating, which shows that the emission of the gamma rays from that radioactive isotope is a random process. Measure the background count from the GM tube when the radioactive sample is not around. Place the sample few centimeters away from the GM tube and measure the radiation or the count rate after every minute. The readings are not same always, and they fluctuate every time. Means that emission of gamma rays is random in time. Okay, so what they say, with the source, take a count for a time or take count rate from a rate meter, meter counter, or read rate meter connected to GM tube, or record number of tracks chamber, or count clicks in a time, or note time when clicks occur, of several readings taken or readings fluctuate, ignore readings random, or time when clicks occur varies. Okay, so I hope Aisha has written a good answer. Okay. Describe what is meant by a gamma ray. Gamma ray is a part of electromagnetic spectrum, and it has very high frequency and it carries a lot of energy with it. Describe what is meant by gamma rays. Gamma rays are electromagnetic waves with high frequency and low wavelength. They travel with the speed of light. Electromagnetic waves, rays, particles, high frequency or small wavelength. So this is, we are done with the section A. There were 8 questions, my dear students. Okay. So we are done with the section A of this paper. So thank you very much for taking out time and watching this video. In this video, we have done the section A of May-June 2010 505422 paper. And the section B of this paper soon I will do, and I will upload in that playlist. And I hope that this video will help you. It will help you to improve your concepts. It will help you to practice the past papers. And if you think that this video has helped you and it can help your friends and your junior, your senior students, your teachers, please share the link of this video onto your Facebook, onto your Instagram, onto your Twitter accounts. When you do this, this helps me to promote my channel. And thank you very much for taking our time and watching this video. One thing I always say, that it is possible that I might make a mistake in ignorance, and please ignore that. And the best thing is, whenever you receive an answer from any teacher, from me, from your old teacher, always check that answer with the marking scheme. It's possible, humanly it's possible, that we might make a mistake. But the actual thing is that we are trying to learn the concept together, and there is possible that we make mistake. I think it's a great blessing for me that I can make these videos and I can share them through YouTube, and I can make the life of so many students and their parents' life easier. Thank you very much. Have a good day. God bless you all.